The equation of a line can be represented by the general form ax plus by plus c equals 0, where the coefficient of x, which is a, and the coefficient of y, which is b, and the constant term c are all integers. The equation of a line is an algebraic equation representing the set of points on the line. The values of a or b may be 0, but they cannot be both 0 at the same time. If a equals 0, then the equation becomes by plus c equals 0, or y equals minus c over b. This represents a horizontal line, where minus c over b is the y-axis intercept. If b is equal to 0, then the equation becomes ax plus c equals 0, or x is equal to minus c over a. This represents a vertical line, where minus c over a is the x-axis intercept. If c is equal to 0, then the equation becomes ax plus by equals 0. This represents a line that contains the origin. The method of finding the equation of a line depends on what information is available. If given 2 points that are on the line, then the formula y minus y1 equals m by x minus x1 can be used. For this formula, we need 1 point and the slope between the 2 given points. The slope can be found by using the slope formula, y2 minus y1 over x2 minus x1. Once the slope is found, it can be substituted for m in the formula, and then one of the given points is used for x1, y1. The equation is then simplified and rearranged. If we are given the line plotted on a Cartesian plane, we can use the formula y equals mx plus c. For this formula, we need the slope of the line and the y-intercept. We start by finding the slope using the slope formula rise over run. We construct a right-angled triangle on the graph to determine the values of the rise and run. We then find the coordinate of the y-axis intercept. The y value of the coordinate will be the c in the formula. When dealing with the equations of parallel and perpendicular lines, they have particular properties which are useful to know. Parallel lines, we know, have the same slope. They also have similar equations. The coefficients on the x and y terms are the same, but they have different constant terms. If we must find the equation of a line that contains a given point and is parallel to a given line equation, we can substitute the given point into the equation, but the constant term will be labelled as d. We can then simplify the equation to find d. Once found, we can rewrite the equation with this constant term. Perpendicular lines, we know, have the slopes that are negative reciprocals of each other. Their equations are also similar. The coefficients of the x and y terms are swapped, and the sign of the new y coefficient is changed. The value of the constant term will also be different. If we must find the equation of a line that contains a given point and is perpendicular to a given line equation, we can substitute the given point into the equation, but the constant term will also be labelled as d. We can then simplify the equation to find d, and once found, we can rewrite the equation with this constant term. All these methods will be practiced later in our questions. If we are given 3 points A, B and C on a line, then these 3 points must be collinear. The slope of AC and the slope of AB are the same. Using the slope formula y2 minus y1 over x2 minus x1, we can substitute the coordinates of A, x1, y1, B, x2, y2, and C, xy into the formula as required. The slope of AC is y minus y1 over x minus x1. The slope of AB is y2 minus y1 over x2 minus x1. As these slopes must be equal, we can equate them. Rearranging the equated slopes gives us y minus y1 is equal to y2 minus y1 over x2 minus x1, all multiplied by x minus x1. Simplifying gives us y minus y1 equals m by x minus x1, which is the equation of a line formula. If we are given 2 points, A and B, on a line, where A is the y-intercept, we can find the slope of the line using the slope formula m equals y2 minus y1 over x2 minus x1. Substituting the coordinates gives us m equals y minus c over x minus 0. Simplifying this gives us m equals y minus c over x. This equation can be rearranged to give mx equals y minus c, which can be further rearranged to y equals mx plus c, which is the formula for the equation of a line. In our first practice question, we must find the equation of the line that passes through the points A, 2, 3 and B, 5, 7. As we are given 2 points on the line, we can use the formula y minus y1 equals to m by x minus x1. To use this formula, we must have the slope of the line and the coordinates of 1 point on the line. To find the slope, we will use the slope formula y2 minus y1 over x2 minus x1. Labelling our points x1, y1 and x2, y2, we can substitute directly into the formula as labelled. This gives us a slope of 4 over 3. In the equation of the line formula, we will use the point A for x1, y1 and the slope 4 over 3 for m. We must now simplify and rearrange the equation to the general format. The rule for rearranging equations over the equal sign is that the operation changes. If something is dividing on one side, when it is moved across the equal sign, it then multiplies. If something is added on one side, then it is subtracted when moved to the other side of the equation. In this example question, the denominator of 3 can be moved across the equal sign, and then we will multiply it by the left-hand side. This results in 3y minus 9 equals 4 by x minus 2. The multiply brackets on the right-hand side can now be simplified by multiplying the 4 by x and then by minus 2. We must now rearrange to the general format ax plus by plus c. We start by moving the 3y term, which is a plus on the left-hand side, and this becomes a minus when moved over the equal sign. Moving the minus 9 over the equal sign, it now becomes a plus 9 on the right-hand side. All terms are now on one side of the equals, so we can just rearrange the order to give us the general format. In this question, we must find the equation of the line that is shown on the graph. As we have the graph of the line, we can use the formula y equals mx plus c. To use this formula, we need to find the slope of the line m and the y-intercept c. To find the slope, we can use the slope formula rise over run. We start by constructing a right-angled triangle with the line as the hypotenuse. From the axis, we can see that the rise is 5 minus 3 and that the run is 6 minus 3. Substituting into the formula gives us a slope of 2 over 3. From the graph, we can read that the y-intercept is the point 0, 1. The c value in our formula is the y value from this point. So the value of c is 1. Substituting the slope and the c value into the equation of line formula gives us y equals 2 over 3 by x plus 1. We can now write the equation in the general format ax plus by plus c. We do this by multiplying each term by 3 to remove the denominator on the slope. We must now rearrange the equation to the correct format, giving us 2x minus 3y plus 3 equals 0. In this question, we must find the equation of the line that passes through the point 2, 3 and is parallel to the line 2x plus 3y plus 7. There are two main methods for solving this equation. The first method we will practice here. We will find the equation using the formula y minus y1 equals m by x minus x1. For this equation, we need a point on the line and the slope of the line. We are told that the line is parallel to the given line. We know that parallel lines have the same slopes. Therefore, we will find the slope of the given line. Using the formula minus a over b gives us a slope of minus 2 over 3. We are told that the point 2, 3 is on the required line, so we can use this point in our formula. Substituting everything gives us y minus 3 is equal to minus 2 over 3 by x minus 2. The denominator of 3 on the right-hand side of the equation can be brought over the equal sign and multiplied by the left-hand side. This gives us 3y minus 9 is equal to minus 2 by x minus 2. We must simplify and remove the brackets, and then we will rearrange to give our answer in the format ax plus by plus c equals 0. This is a repeat of the last question, but we will use a different method. We are told that the required line is parallel to the given line. We know that parallel lines have the same coefficients on the x and y terms, but have different constant terms. Our required line will be 2x plus 3y plus d. We must now find d, the constant term. We are told that the point 2, 3 lies on the required line, so we can substitute the point directly into the equation. 2x plus 3y plus d equals 0. Simplifying allows us to find the value of the constant term. This gives us our required equation of 2x plus 3y minus 13 equals 0. In our last practice question, we are asked to find the equation of a line that contains the point 2, 3 and is perpendicular to the line 2x plus 3y plus 7. We know that with perpendicular lines, the coefficients on the x and y terms are swapped, and the sign of the new y term is changed. The equations will also have different constant terms. Our required line will be 3x minus 2y plus d. We must now find d, the constant term. We are told that the point 23 lies on the required line, so we can substitute the point directly into the equation. Simplifying allows us to find the value of the constant term d. In this case, our d value is 0. Our required equation is therefore 3x minus 2y equals 0. From this equation, as it does not have a constant term, we know it contains the origin 0, 0. We are now ready to practice exam questions. Please pause the video when the questions appear and attempt the questions. Your confidence will grow with practice. When ready, press the play again to see your progress. We are told that the line P has a slope of 1 and contains the point 15. We are asked to find the equation of the line P. We are also asked to write the answer in the form ax plus by plus c, where a, b and c are an element of integers. We start by using this equation of the line formula, as we have both the slope and a point. We can substitute them directly as labelled. Simplifying gives us y minus 5 is equal to x minus 1. We will now rearrange the equation into the required format, giving us the equation of P as x minus 1 plus 4. Here we are told that the line Q is perpendicular to the given line P, and that it contains the origin point 0, 0. We are asked to find the equation of the line Q. We will use this equation of the line formula, but first we need to find the slope. We were told that the required line is perpendicular to the given line. We know that the slopes of perpendicular lines are negative reciprocals of each other. Therefore, we will find the slope of the given line P, and from it find the slope of the required line Q. Using the slope formula minus a over b, the slope of P is 1. The negative reciprocal of 1 is minus 1. Therefore, the slope of line Q is minus 1. We are now ready to substitute our found slope and the origin point into the equation of the line formula. Simplifying gives us y equals minus 1x. Rearranging gives us the equation of Q as x plus y equals 0. Here we are told that the line L contains the points A, 4, 5 and B, 2, 0. We are asked to find the equation of the line, and we must give our answer in the form ax plus by plus c equals 0, and that a, b and c are elements of z, which are integers. We will start by finding the slope of the line, as we are given 2 points. We will use this slope formula. Labelling our points, we can substitute them directly, and we get a slope of 5 over 2. Using the equation of the line formula, we can substitute our slope that we found and use one of the points. Here we will use the point A. Substituting everything, we now need to simplify. We can bring the denominator from the right-hand side to the left-hand side and multiply. Rearranging gives us 5x minus 2y minus 10 equals 0, which is the equation of the line L. In this question, we are asked to find the equation of the line BC, where B is the point 6, 3 and C is the point 5, 5. We were also asked to give our answer in the general form. As we are given 2 points, we will use this formula to find the slope. First labelling our points and then substituting them. we find the slope is -2. Using this equation of the line formula, we can substitute the slope and one of our points. Here we will use the point B, 6, 3. Simplifying and rearranging gives us the equation of the line BC as 2x plus y minus 15 equals 0. Here we are given a diagram that shows the line PQ and the line QR. We are given the coordinates of the points PQ and R, and we are asked to find the equation of the line PQ. We must also give our answer in the general form, where a, b and c are elements of integers. We must first find the slope of the line PQ using our slope formula. We begin by labelling our points and substituting them into the formula, which yields a slope of 3/4. We will use this equation of the line formula and substitute our found slope and the point P. We will move the denominator over the equal sign and multiply it by the left-hand side. Simplifying and rearranging gives us the equation of the line PQ as 3x minus 4y minus 4 equals 0. In this question, we are told a line passes through the point A, -1, 2, and B, 0, -2. We must find the equation of the line and write it in the form y equals mx+c, where m and c are elements of integers. We must first find the slope of the line using this slope formula. Labelling and substituting our points yields a slope of -4. Using our equation of the line formula and substituting the found slope and one point A, -1, 2, we can now simplify and rearrange into the required format, giving us an equation of the line as y equals -4x minus 2. Here we must find the equation of the line that passes through the point P, 6 minus 3, and we are told it is perpendicular to the line L, whose equation is 3x minus 4y equals 5. We are asked to give our answer in the format ax plus by plus c, where a, b and c are elements of integers. In this question, we are told that the required line is perpendicular to the given line L. This will help us get the slope, as perpendicular slopes are negative reciprocals of each other. We start by finding the slope of the line L using the formula -a/b. The slope is found to be 3/4. Inverting the slope and changing the sign gives us the perpendicular slope, which is the slope of the required line. Using our equation of the line formula, we can substitute the perpendicular slope and the point P. Bringing the denominator from the right-hand side over to the left-hand side, we multiply it by y plus 3. Simplifying and rearranging gives us the required equation of 4x plus 3y minus 15 equals 0. Here we are asked to find the equation of the line that passes through the point -2, 7 and has a slope of 1/3. We are asked to give the answer in the general format, where a, b and c are integers. We will use this equation of the line formula. As we are given the slope and a point on the line, we can substitute everything directly into the formula. We will first bring the denominator over the equal sign and multiply it by the left-hand side. Simplifying and then rearranging gives us the required equation of the line. In this question, we must find the equation of the line that passes through the points 0, 6 and 2, 9. We must first find the slope using the slope formula. Labelling our points and substituting gives us a slope of 3 over 2. We can now use our equation of the line formula and substitute the found slope on one of our points, 0, 6. We first bring the denominator of 2 over the equal sign and multiply it by the left-hand side. Simplifying and rearranging gives us the required equation of the line.